Yeah, hi Caleb.
How are you doing?
Good. Alright, what are we going to do today?
Complex numbers.
Okay.
So, I guess what...
They're easier than they sound.
Yeah.
Go ahead if you have some problems to look at.
Alright, yeah. Like, I guess this one might... Let's do,
I can make up a few problems just to talk about it. What's this equal to?
okay. Yeah, see, I guess that's, I don't know.
Okay. The way to handle this is based on the rule that the square root of AB is equal to the square root of A times the square root of B.
Okay.
Therefore, whenever you have the square root of a negative number, separate it into this.
Okay.
And then always you can replace that with I.
Right.
So that would be equal to 6I.
Okay, all right.
So that's straightforward enough. Whenever you're taking the square root of negative numbers, that's when you get imaginary answers.
Okay.
And of course, whenever you're trying to solve a quadratic and you plug into the quadratic formula and you end up with the discriminant being negative, you're going to end up with imaginary numbers for that answer.
Okay.
Now, there's a few other things. Actually, I can cover imaginary numbers probably in a half an hour here.
Okay.
If you, here's the standard form for imaginary numbers. A plus bi, where A is the real part and 2I is the imaginary part.
Okay.
Okay. There's a few things you need to be able to do. One is add, subtract, multiply, and divide imaginary numbers.
Okay.
Adding, subtracting, and multiplying are very straightforward. It's exactly what you would expect. What would you think the answer to this would be?
10I minus 1.
10.
Or, excuse me, 10, yeah.
Okay.
10I minus I, yeah.
10 minus I. In other words, you add the real parts together and you add the imaginary parts together.
Okay.
Okay? So adding and subtracting is that straightforward. In other words, if I put a minus sign in there, I want to subtract the two, then the answer is minus 4, and then you'd have 2I minus a minus 3I, which would give you plus 5I.
Sure.
Okay? So adding and subtracting is a piece of cake. Let's multiply.
All right.
Well, you're going to FOIL it. I don't know. Is that a term you're familiar with? They don't tend to do FOIL anymore. I prefer ET, which means every term by every term.
Okay.
FOILing applies fine for binomial times a binomial like this is. But if I had A plus B plus C times D plus E, FOIL doesn't work. But every term by every term does. And every term by every term works with a binomial times a binomial also. So multiply these. What's the first term going to be?
In this problem here? 21.
Next?
Negative 9I.
Next?
14I. Plus 14I.
Plus 14I. Okay. And then the last term is the only tricky one.
Negative 6I squared.
Okay. And what is I squared equal to?
Negative 1.
Okay. So this becomes 21 plus 5I minus a minus 6.
Okay.
Okay. Or 27 plus 5I. Okay. All right. complexity comes when you're dividing imaginary numbers.
Okay.
If I divide 5 plus 2i by 3 minus 4i, that's not really a division problem, any more than if I say, what is 1 over the square root of 2? That's also not a division problem.
Okay.
How do I solve this?
Well, you can't have the square root in the bottom
What
there.
do you do?
Gosh, I don't know, reciprocal
It's
maybe?
called rationalizing the denominator. In other words, you're correct. You cannot have an irrational number in the denominator. So to solve that problem, I'm going to multiply the top and bottom by square root of 2, and I end up with 2 over 2, which is the proper way to write 1 over square root of 2. Notice that I didn't do any dividing at all.
Sure.
I rationalized the denominator. Well, with imaginary numbers, it's exactly the same thing. You're not going to rationalize the denominator, but you're not allowed to have imaginary numbers in the denominator for a final answer. So what I'm going to do is a process that I call realifying the denominator. I'm going to turn the denominator into a real number, and what I have to multiply to do that is by the conjugate. The conjugate of an imaginary number is just with the sign different in the middle. Okay, well, since I multiply the bottom by that, I got to multiply the top by that also. And the advantage of multiplying by the conjugate is you get rid of the imaginary part. The only thing you have left is 9 minus 16i squared, because the two middle terms cancel out when you do this multiplication. Okay. So my new denominator is 9 minus 16, so it's 25. So I've turned it real. Okay. The new numerator is still going to have imaginary numbers in it, but that's okay. It's much like rationalizing the denominator. It's okay to have an irrational number in the numerator.
Okay.
So the numerator is going to be 15. We have plus 6i plus 20i. That's plus 26i. And then we have plus 8i squared, which is the same as minus 8. So that becomes 7 plus 26i over 25. So that is the answer, unless the teacher says put it into A plus BI format.
Okay.
That's a very specific format, and we're not in that format here.
Okay.
In order to get it into that format, I just need to split this into two fractions. 7 over 25 plus 26 over 25 times I. See what I did?
Yes.
Okay. And this would be the perfect answer because it is in A plus BI format.
Okay.
Okay? All right.
Yep.
So that's addition, subtraction, multiplication, and division of imaginary numbers.
Okay.
Now, there's one last thing that they always take you through, and that is the pattern that develops when you start taking these to, what's I cubed?
That's square root negative 1.
You're going to multiply I times negative 1, right?
Yeah.
So what's that?
Just I times 1
Negative I. Negative
yeah.
I. Okay? And then I to the fourth, what's that going to be?
Negative I squared.
What's I squared times I squared? That's I to the fourth. What's minus? Yeah, there you go. Okay? Now it starts repeating.
Okay.
I to the fifth is I. I to the sixth is I squared. I to the seventh is I cubed. And I to the eighth is 1. So what is I to the 500th power equal to?
Oh, man. God, I don't... Whew.
Is it divisible by 4?
Yeah.
Then it's 1.
Okay. Oh, okay.
I to the 503rd power would be what?
Well, that's just going to be an I, yeah?
Count starting with, in other words, if I to the 500th is 1, then
Yeah.
I to the 501 power would be I. So this 503 is going to be the same as I cubed. So that's going to be minus I.
Okay.
And that's how you do those.
Okay.
Okay? And that's almost everything I can think of about imaginary numbers that you're going to have to know.
Okay.
There's not, let me ask you a few questions, make sure you understand what we just covered. What's the conjugate of that?
2 plus 3I.
What's the conjugate of that?
Negative I.
What is that?
This is going to be 6 minus negative 12, so 18.
Okay. All right. That's all I can really think of off the top of my head. That's my imaginary number 101 lecture.
Okay.
Okay? So if you have some problems that we can maybe cover for the next 15 minutes just to practice what we've just covered.
Yeah. Geez. Hold on, let me make sense of this one real quick. And then we can... Oh, yeah, okay. So it's in the quadratic formula. That's how it's set up.
Okay.
Tell
me what the quadratic formula is.
Negative b plus or minus the square root of b minus 4 times
b squared minus 4ac.
Yeah, over 2a.
Okay. Now, let me help a little bit with memorizing that.
Okay.
You got 2 parts to the quadratic formula.
All right.
Okay? At least I call them 2 parts. There's that part. What does that look like? What else is that?
That's division probably.
That's the x-coordinate of the vertex, right?
Okay.
Yeah, if I gave you a quadratic, and I said, where's this vertex? You would use minus b over 2a to find the line of symmetry, which is the x-coordinate of the vertex.
Okay.
Okay? At least you should have learned that somewhere along the line in algebra or somewhere. But most people find the vertex by this formula at some point. If you haven't learned that, it's worth learning it, and it's worth memorizing. That the x-coordinate of the vertex of a quadratic is minus b over 2a, as long as that quadratic is in standard format. Okay? So each of these help you learn the other. If you know that, then it helps you remember the quadratic. If you know the quadratic, it helps you remember that. Well, the only other part of the quadratic is this complicated part inside the radical sign.
Yeah.
b squared minus 4ac. That is so important it has its own name. That's called the discriminant.
Okay.
Why does it have its own name? Because if you're going to solve a quadratic and you want to determine whether or not they have real solutions or imaginary solutions, then you can examine the discriminant as your first step. And if b squared minus 4ac is a positive number, then you are going to have 2 real solutions. If it's a negative number, you're going to have 2 complex solutions. And if it's precisely equal to 0, you're going to have 1 real solution.
Okay.
Okay? Let's talk about that for a second. Let me put up a quadratic here and you tell me whether it has real solutions or imaginary solutions. What does the discriminant tell you about these two solutions?
Well, let me hold on. That's 6 plus or minus 6 squared minus 4 times 5. 20, 36. That's just going to be, it's going to be a real, two real.
Two real, exactly. Exactly. If I change the problem and make it like this, now you have a negative inside the radical.
Right.
And you're going to end up with two complex solutions.
Okay.
Let's see. What else? Do you have any specific problems?
Yeah, so the one that I was, we were going to talk about, so it's in quadratic form, so it was -4 plus or minus square root of 4 squared minus 4 times 1 times 8 over 2.
You know, and I definitely recommend writing it like this.
Okay.
The reason being is that if you try to do this whole step in your head, it's real easy to get the signs wrong.
Right.
In other words, frequently that's a -8.
Okay.
Then you have two negatives. And sometimes you can have three negatives. In other words, you could have a -1, you could have a -8, and then you got negative, 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 and it's real easy to make a mistake. So
Right.
doing it one step at a time is great
Okay.
for accuracy. Okay, so what does this reduce to?
Inside there?
Uh-huh.
16 minus 32.
So that'd be -16, right?
Yes.
Okay, now simplify that.
Okay, hold on. -4 squared 16. So that's just going to be -4 plus or minus I root 4.
Not root 4, root 16. In other words,
Oh, okay. I see.
In other words, that's equal to -1 times that, which is 4i.
Okay.
So that thing turns into a 4i. What's that become?
So can we work in the denominator now?
Yeah, well, we can divide top and bottom by 2.
Right. So we can just do. That's just going to be 2 plus or minus 2i.
Minus 2
Oh yeah. Okay.
plus or minus 2i.
Sure.
Okay, so what are the solutions?
So you set these to 0, correct?
No? The biggest thing that not everybody is totally clear on is what that plus or minus means.
Oh, okay.
In other words, the solutions are -2 plus 2i and -2 minus 2i. Those are your two solutions to that quadratic.
Okay.
And you would want to take it that far. Now, your teacher may let you get away with leaving it like that, where
Okay.
the solutions are -2 plus or minus 2i. That's perfectly acceptable as long as you understand exactly what it means.
All right.
Okay. All right.
All right. Let's do a big one. We're gonna. It's a bunch of different binomials and trinomials. We got to kind of multiply everything back together.
Okay.
X minus 1 times x minus 1 times x plus 4 minus I times x minus a -4 minus I.
Which is x plus 4.
Plus 4I.
Is that right?
Sure, okay. Yeah.
Okay. In other words, you end up with a problem here that if your solution was 4 plus I and 4 minus I, then your linear factor is x minus that and x minus that. Okay? Now if you remove the parentheses, this turns into x minus 4 minus I, and this one turns into x minus 4 plus I.
Okay.
So this minus, this initial minus, or this sign right here, is going to be the same. That's why I didn't like the way you expressed it, where you said x plus 4 and an x minus. It's x minus in both cases. It's just that if you use parentheses, it turns into, in other words, this is the conjugate of this.
Right.
But it's x minus in both cases. But by the time you remove the parentheses, you end up with that, only it's a plus because it's a minus 4 was the answer. In other words, this was really what the solution was minus 4 plus I and minus 4 minus I. And that turned out, I wrote it wrong, excuse me. That's x plus 4 minus I and x plus 4 plus I.
Okay.
Okay, so that's how we got those two linear factors. Even though they're complex, they're linear. Now, the thing is that imaginary solutions always come in pairs. Always come in conjugate pairs.
Okay.
Okay, if you have this is going to be a 4th degree polynomial.
Right.
And you can't have a single imaginary solution to a polynomial. If you have a solution to a polynomial that is that, then you have two solutions. Another factor is automatically that.
Okay.
Imaginary solutions never come in singles. They always come in pairs.
Okay.
Now, if I multiply that times that, I'm going to eliminate the imaginary part of it.
Right.
And so that's what we should do first.
Okay.
Is the quicker we can get rid of the I, the easier this problem will become. We don't want to be multiplying x minus 1 times this. I mean, we'll have a ton of i's, but then it'll just be harder to simplify. So a lot of the secret of this problem is to figure out which two to multiply first.
All right.
Let's multiply this trinomial by this trinomial. What do you
Okay.
start, y'all?
So, yeah, x squared.
Go ahead and just put every term, and then we'll see what cancels. Okay.
Okay, so yeah, x squared plus 4ix.
Hold on.
Oh, sorry, my bad. Yep, I wrote it down wrong. That's just plus 4x.
Okay.
That's a positive. Plus ix. Plus 4x. Plus 16. Plus 4i. Minus ix. Minus 4i. And negative I squared.
Okay. Now, that ix cancels with that ix.
Sure.
That minus 4i cancels with that plus 4i.
Okay.
And this I squared turns into a minus 1.
Okay.
So what do we end up with? We end up with x squared plus 8x plus 16 minus a minus 1 plus 17.
Okay.
Okay? So I can replace these two trinomials with this quadratic.
Okay.
Now let's multiply these two together because we can do that fairly easily. I think that's the simplest thing to do. We could multiply these binomials by this quadratic, the trinomial.
Yeah.
Yeah, it's just as easy to multiply these two together, producing a second trinomial, and then multiply the trinomial by the trinomial. And
Okay.
mainly because that's relatively simple. You do enough of these and you don't have to FOIL it. What's that equal to?
X squared minus 2x plus 1.
Yeah. And if you don't have that memorized, you probably should try to memorize it.
Okay.
Because it's much easier to just know what that binomial squared is rather than having to FOIL it every single time. And only because you're going to have to do it a million times over the next few years.
Right.
So you might as well memorize what it is. Okay, and then put this together.
X to the 4th plus 8x squared.
Hold on.
Plus 17.
Hold on.
That's an 8x, so that's 8x cubed.
Okay.
Plus 17x squared. Minus 2x cubed. Minus 16x squared. Minus 34x. Plus x squared. Plus 8x. Plus 17.
Okay, simplify. There's always only one of those.
Okay, yeah.
Okay, so we don't need to search our answers for more x to the 4ths.
Okay.
What's our total x cubes?
6x cubed plus 6x cubed.
Plus 6x cubed. Our total x squareds?
2x squared.
And x?
X is 34. Negative. Oh, jeez. That's a definite.
26.
Yeah, there's 26x.
And then there's always only going to be one number, I think, also.
Right, it's just
As
plus
long as
17.
you're not having any i's involved. If there's an I involved, there might be an I squared to go with that number, but if it's all just real numbers, I think you're always only going to have that single number.
Okay.
All right. I hope that was helpful.
Yeah, absolutely. Thank you.
You're welcome. And your sister going to do it on a different computer, or is she going to do it on your computer?
I'm pretty sure. I think she's going to try to do it on her computer, so we'll see what happens.
We'll sign off then. Because,
All right, great.
hold on, I may have to reboot. Tell her it may be a few minutes.
Okay.
Okay? I think I'm going to reboot my computer. All right. Talk to you later.
All right. See ya.
Bye-bye.